Here are three more ideal gas law practice problems. These are all going to be word problems. We're going to start here. We're on question 4. Remember, with word problems, first thing you want to do is identify what you're solving for and identify the other variables that are involved. So let's read this one. At what volume is what volume is occupied by 0.157 moles of oxygen at 28 degrees Celsius at a pressure of 0.998 atmospheres? So the first thing we notice, it says what volume. So we know that volume is going to be our unknown. We're going to be solving for volume. Let's look at what else we have here. 1.157 moles, 28 degrees Celsius at a pressure of 0.998 atmospheres. So that is what we are working with here. So let's go ahead and write out, like in this format, what we have. So our pressure, this always helps for organizational purposes, our pressure is 0.998 atmospheres. Our volume, we do not know. Our moles is 0.157 moles, and our temperature is 28 degrees Celsius, which means we need to add 273 to that, and that is going to give us 301 Kelvin. So that is our actual temperature that we are going to use in our equation. It has to be converted to Kelvin first. Now let's go ahead and put it in equation form. Our P is 0.998. Our V, we don't know. Set that equal to. Our N is 0.157. Our R is always the same. And our T is 301. So we got 0.998 V equals, and then we'll do 0.157 multiplied by 0.8206, and then finally 301, and that's going to equal 3.88. So now we need to divide both sides. Remember, you look and see which side has the variable still on it. It's the 0.998 side, which means we divide both sides by 0.998, tab 0.998, and we are going to then solve for V. So V is going to equal 3.88 divided by 0.998. It's going to be very close to the same number, and it is. We'll go 3.89 liters is going to be the answer you should have gotten for this question. So check your work. If you need to, go back and redo it. We have two more examples here. Question number 5, same thing. Let's look through and see what we're solving for. So it says what mass of carbon dioxide, so what mass of carbon dioxide is needed to fill an 80.0 liter tank to a pressure of 150 atm at 27 degrees Celsius. So let's underline what we have here, 80 liter tank, 27 degrees Celsius, 150 atm, and then let's go ahead and write it over here. So our P that we have is 150.0 atm, our V is 80, our N we don't know, and our T is 27 Celsius, so we have to add 273 to that, plus 273, that's going to equal 300 Kelvin. So that is our temperature. And now let's go ahead and plug it into the equation. There's an additional step we'll do at the end that I think may surprise some of you, but we'll see. 150 is our P, 80 is our V, set that equal to. We don't know our N. Our R is always 0.08206. And our T in this case is 300. 150 multiplied by 80 is 12,000. Set that equal to, and then we have 0.08206 multiplied by 300 is 24.6 N. Now we need to divide. We got to find our variable and divide both sides by that number. So our variable is on the right, so we got to divide both sides by 24.6. Divided by 24.6, divided by 24.6, so 12,000 divided by 24.6. Our answer is going to be N equals, at least our initial answer, you'll see there's a little change we have to make, N equals 487.8 moles. So we solved for N, right? So that's our answer, right? This is actually kind of a trick question. It says what mass of carbon dioxide is needed to fill, which means we have to convert moles into grams. If you remember how to do that, that's where you set up your little dimensional analysis fence just like that, and we would put 1 mole on bottom, 1 mole carbon dioxide on bottom, and that is equal to, if you remember, 16 times 2 plus 12. It's 44 grams is the molar mass of carbon dioxide, so then you have to do 487.8 times 44. So the actual correct answer, and kudos to you if you got this right, is 21,463 grams of carbon dioxide. That is the correct answer. I imagine a lot of you probably got 487.8 and circled that as your answer, but because it's asking for mass at the very end, we needed to convert to grams. So that's a little bit of a trick question there, so go back and check that for sure. One more practice question. Question number 6 right here. Same thing, another word problem. So let's identify what we're solving for. It says how many moles of gas would you have? So moles of gas, so that's what we're going to solve for in the end. No tricks this time. Would you have if you had a volume of 38.0 liters under a pressure of 1432 millimeters mercury at 273 Kelvin. So let's go ahead and write this out. Our P is 1432 mmHg. Our V is 38.0. Our N we don't know, and our T is 273 Kelvin right there. So first thing we need to do, we need to change pressure into ATM. To do that, we need to divide by 760. So you got 1432 divided by 760, and that's going to give you 1.88 ATM. So that is the new pressure we're dealing with. Always have to do that conversion first. If you didn't do that conversion, you should go redo this problem right now before watching the rest. All right, now let's put it into our equation format. You have 1.88 multiplied by 38, set equal to, we don't know our N, 0.088206, and then 273. 1.88 multiplied by 38 is going to give you about 71.6. Set that equal to 0.08206 multiplied by 273 is going to give you 22.4 N. And now because the N is on the right, we need to divide both sides by 22.4 divided by. We'll go divided by 22.4, 22.4, whoops, that's 3, 22.4 there, 22.4 there. And then we will solve for N. So 71.6 divided by 22.4 is going to equal 3.2. So N equals 3.2 moles of gas in this situation. So that is going to be the answer that you should have gotten for this question. N equals 3.2 moles. So go ahead and check that. That's our last of our example problems, the last of our guided practice here. Hopefully you did well. You can go back and do the previous 3 problems again if you need additional help. But that is the ideal gas law. Good luck and farewell.